I'm going to show you exactly how to follow termites to find diamonds and gold that other prospectors completely miss. You're about to learn not just the termite tracking method, but also the 3 telltale signs that indicate high-value deposits are nearby, plus the simple household test that confirms if what you found is worth thousands or just worthless rock. Before you start your next prospecting adventure, you need to know these underground secrets that professional miners have been using for decades in Australia, South Africa, and right here in North America. What you're about to discover will completely change how you think about finding precious gems in nature, and I'll prove it to you in the next 30 minutes. But before we dive in, if you're serious about finding diamonds and other precious stones, make sure to subscribe and hit the bell icon, because we share advanced prospecting techniques every week that most hunters never learn. All right, let's get started. Foundation section. Now here's where it gets interesting. Most people think finding diamonds and gold requires expensive equipment, geological surveys, or pure luck. That's completely wrong. Nature has been providing us with perfect guides to underground treasure for millions of years, and we've been walking right past them every single day. Termites are essentially nature's miners, and here's what blows most people's minds. These insects have been doing advanced geological surveying for over 250 million years. Unlike what most people think, these insects don't just build random mounds wherever they feel like it. They're following specific geological patterns, soil chemistry indicators, and mineral concentrations that lead directly to the same zones where diamonds and gold naturally occur. Professional prospectors know that termite colonies require particular soil conditions and mineral content that coincidentally, and this isn't really a coincidence, align perfectly with areas where precious gems and metals have been deposited by ancient geological processes. Think about it logically. Termites need specific pH levels, drainage characteristics, and soil stability for their massive underground cities. These same conditions create the perfect environment for heavy mineral concentration. Here's what most people don't know, and this is going to change everything about how you prospect. Termites bring subsurface material up from depths of 20 to 30 feet, sometimes even deeper than 50 feet in established colonies. That's exactly the zone where diamonds and gold particles settle after being transported by ancient river systems, glacial movements, and volcanic activity over thousands of years. When termites excavate their tunnel systems, they're literally bringing treasure samples directly to the surface for you, pre-concentrated and ready for inspection. They've done all the heavy digging, all the soil processing, and they've even sorted materials by weight and density through their natural construction behaviors. But there's something even more important that you absolutely must understand before we dive into the specific methods. The reality check you need to hear, and this might disappoint some of you initially, but it's going to save you months of frustration and wasted effort. You will not find huge diamonds sparkling in the sunlight like some Hollywood treasure hunt movie. That fantasy has caused more disappointment and abandoned prospecting careers than any other misconception in this entire field. The big sparkly diamond just sitting on top of the ground scenario has probably ruined more potential prospectors than bad weather and difficult terrain combined. What you will find, if you follow the methods I'm about to teach you, are small, rough diamonds that look more like broken glass or cloudy pebbles, and gold particles that appear as tiny flakes, grains, or irregular nuggets mixed with soil, clay, and organic debris. These finds require trained eyes, systematic processing, and proper identification techniques to recognize their true value. This is the technique that changed everything for me, and it's probably going to revolutionize your approach too. Instead of randomly searching riverbeds, creek banks, or old quarries like most beginners do, and I did this too when I started, experienced prospectors know to map termite activity first. The termites have already done the deep excavation work, the geological sampling, and the heavy lifting. You just need to know how to read the signs they leave behind and interpret their construction materials. The challenge isn't finding termites. They're literally everywhere in the right climates, from tropical regions to temperate grasslands. In fact, in some areas you'll find dozens of mounds per square mile. The real challenge, the skill that separates successful prospectors from weekend hobbyists, is identifying which termite colonies are sitting directly on top of mineralized zones. That's exactly what you're about to master in this video. I'll show you the specific visual indicators that professional miners look for, the soil composition signs that reveal subsurface treasure, the simple field tests that can be performed with basic tools, and the advanced recognition techniques that separate promising locations from complete waste-of-time spots. But here's what makes this method so powerful compared to traditional prospecting. Termites are active year-round in most climates. Their mounds are permanent structures that remain accessible in all weather conditions, and they continuously bring up fresh material from depth as they expand their colonies. You're not dependent on seasonal water levels, recent rainfall, or temporary exposure conditions. Wait until you see what happens next. We're going to build your knowledge in 4 progressive layers that take you from complete beginner to advanced practitioner. First, visual identification of the right termite indicators and soil characteristics. Second, location strategy for finding the most geologically promising areas. Third, practical extraction methods using tools that cost less than $20. And fourth, advanced recognition techniques that professional miners use to assess quality, value, and long-term site productivity. By the end of this video, you'll have a complete system for termite-guided prospecting that you can implement immediately, using budget-friendly tools and targeting locations that are accessible to any beginner, regardless of your experience level, physical fitness, or equipment budget. More importantly, you'll understand the geological science behind why this method works, so you can adapt these techniques to your specific region and local conditions. Progressive education layers. Layer 1. Visual identification. First, you have to understand exactly what you're looking for, and this is where most beginners make their biggest mistakes. Not all termite mounds indicate mineral deposits. In fact, the vast majority don't contain anything valuable. Here's the part that surprises most people. The termite mounds you want have distinct visual characteristics that completely separate them from ordinary colonies. And once you know what to look for, the difference becomes obvious. The primary telltale sign that you're dealing with a potentially profitable location is unusual soil coloration in the mound construction material. Look specifically for termite mounds with distinct reddish-brown, yellowish-orange, or deep rust-colored streaks running through the construction material. This discoloration comes from iron oxides, hydroxides, and other mineral compounds that termites bring up from deeper geological layers, where heavy minerals naturally concentrate. Regular termite mounds, the ones you want to ignore, appear relatively uniform in color, usually gray, tan, or light brown throughout their structure. They might show some natural variation, but it's subtle and consistent. The mineral-rich mounds show dramatic color variations, distinct banding patterns, and sometimes even metallic sheens visible in bright sunlight. The secret is understanding texture and weight differences that most people completely overlook. Mineral-rich termite soil feels noticeably heavier than regular soil when you pick up a handful and compare it side by side. This increased weight comes from higher specific gravity due to metal particles, dense mineral crystals, and heavy oxide compounds mixed throughout the construction material. You'll also notice a distinctly gritty texture when you rub the soil between your fingers. It's not smooth and clay-like, and it's not loose and sandy. Instead, it has tiny hard particles that create noticeable resistance and a slightly abrasive feeling. These particles are often microscopic fragments of quartz, garnet, ilmenite, and other indicator minerals that suggest valuable deposits nearby. All you have to do is systematically scan for metallic flecks, visible in the mound material under different lighting conditions. These appear as tiny reflective spots that catch and redirect sunlight differently than surrounding soil particles. They maintain their reflective quality when you change viewing angles, unlike organic debris or clay particles that might show temporary shine. Don't confuse these metallic particles with mica flakes, which are extremely common and worthless for our purposes. Mica appears shiny and reflective, but it's flat, papery, and breaks into thin sheets when pressure is applied. True metal particles maintain their reflective quality from multiple angles, feel noticeably harder when scratched with a fingernail or knife blade, and often show characteristic colors. Gold appears yellow even in small particles, while native copper shows distinctive reddish tints. Unlike what most people think, diamonds in termite mounds absolutely do not look like jewelry store gems or anything you've seen in movies. You're looking for small, rough stones with what geologists call adamantine luster. That's a specific type of brilliance and light reflection that's completely different from glass, quartz, or any other common mineral. Diamond fragments in termite soil appear as irregularly shaped, clear to slightly yellowish crystals with extremely high hardness and sharp, well-defined edges. Even after being tumbled and moved around by termite construction activity, they maintain those sharp crystal edges and resist scratching or damage. Here's what professional diamond sorters look for when examining termite mounds: cubic or octahedral crystal shapes, even in broken fragments. These geometric forms, cubes, triangular pyramid shapes, and eight-sided crystals, are unique to diamond crystal structure and remain clearly visible even in small pieces, weighing less than a carat. Another key identification feature is crystal face development. Even tiny diamond fragments often show perfectly flat, mirror-like faces that reflect light uniformly. These faces meet at precise angles, exactly 90 degrees for cubic crystals, or the specific angles of octahedral geometry. Common minerals like quartz might appear similar to untrained eyes, but they show different crystal angles and less perfect face development. That's how you'll distinguish real diamonds from the dozens of look-alike minerals that cause beginners to get excited about worthless finds. Glass fragments show curved surfaces and stress fractures. Quartz crystals display hexagonal symmetry and different hardness characteristics. And most other clear minerals lack the extreme hardness that allows diamonds to scratch literally everything else you'll encounter in nature. The weight test is absolutely critical for diamond identification in field conditions. Diamonds have a specific gravity of 3.52, which means they feel noticeably heavier than glass, 2.5, quartz, 2.65, or topaz, 3.5, of the same size. When you're examining potential finds, always compare the weight-to-size ratio against known materials. A suspected diamond should feel substantially heavier than a piece of glass of equal dimensions. One final identification tip that separates experienced prospectors from beginners: pay attention to associated minerals found in the same termite mound. Diamonds rarely occur alone. They're typically accompanied by specific indicator minerals that we'll cover in detail in the location strategy section. Layer 2. Location strategy. Now here's where it gets really interesting, and this information is going to save you years of random searching in unproductive areas. Not every location with termites will produce valuable finds, regardless of how promising the mounds might appear. The geological context determines everything, and I'm going to break this down in simple terms that don't require a geology degree or expensive reference materials. That's how you'll identify prime locations for diamond prospecting. Look for areas with kimberlite pipes or alluvial deposits within a reasonable distance. In simple terms that anyone can understand, kimberlites are ancient volcanic formations. Think of them as underground chimneys that brought diamonds up from deep in the Earth's mantle over millions of years ago. These formations create the source areas where diamonds originally reached the surface. Alluvial deposits are areas where water, ancient rivers, streams, and glacial melting has transported and concentrated gold, diamonds, and other heavy minerals over thousands of years. These deposits often occur far from the original source rocks, but they create concentrated areas where valuable finds are much more likely. Before you find your first diamond, you absolutely must understand the indicator minerals that professional prospectors use to identify potentially productive areas. When termites bring up soil from depth, they also bring up these telltale minerals that suggest valuable deposits nearby. Here's what to look for in termite mounds. Garnet crystals. These appear as deep red, wine-colored, or sometimes orange crystalline particles, with a distinctly glassy appearance and high hardness, 7 to 8 on the Mohs scale. They feel noticeably heavy for their size and often show well-formed crystal faces, even in small fragments. Ilmenite. This appears as black, highly metallic particles with an almost mirror-like luster. Ilmenite feels extremely heavy for its size due to high iron and titanium content. It's often magnetic or weakly magnetic, and it maintains its metallic appearance even when scratched or damaged. Chromite. Look for dark metallic particles with greenish-black coloration and strong magnetic properties. Chromite often appears in small, irregular grains, but maintains consistent color and metallic luster throughout the particle. Pyrope garnet specifically. This is the bright red variety of garnet that's almost always associated with diamond-bearing formations. Pyrope appears more intensely red than common garnet varieties and often shows perfect crystal development, even in tiny fragments. The telltale sign that you're in a genuinely productive area is finding multiple indicator minerals together in the same termite mound or in mounds within a small geographic area. One type of indicator mineral might be coincidence. Geological processes can concentrate individual minerals through various non-diamond-related processes. But finding 3 or 4 different indicator minerals together strongly suggests you're likely in a kimberlite field or diamondiferous region. Here's the location strategy that experienced prospectors use to maximize their success rates. Target areas within 50 kilometers of known diamond mines, historical mining districts, or documented kimberlite occurrences. This isn't because you're going to find the same deposits. Those have already been commercially extracted. It's because the geological conditions that created those deposits often extend over much larger areas than the specific sites that were commercially developed. For gold specifically, you need to focus on termite colonies in areas with quartz veins, visible in nearby rock outcrops, road cuts, or stream exposures. Gold occurrence in nature is strongly associated with quartz. Not because quartz contains gold, but because both minerals form under similar conditions, hydrothermal conditions, and often occur in the same geological environments. Look for white, milky, or clear quartz veins cutting through darker host rocks. These veins often appear as bands, irregular masses, or network patterns in rock exposures. Termites excavating near these formations have access to soil layers where gold particles have been deposited through erosion and weathering of the original quartz gold veins. But there's something even more important about elevation and drainage patterns that most prospectors completely ignore. The most productive termite colonies, from a mineral prospecting standpoint, are usually found on slight elevations, not hilltops or ridge crests, but gently raised areas that provide good drainage without being too high above local base level. This positioning is crucial because it allows termites to access deeper soil layers and bedrock without encountering waterlogged conditions that would interfere with their extensive tunneling operations. At the same time, these elevated positions are often where ancient streams and rivers deposited their heaviest loads during flood events, creating concentrated deposits of gold and other heavy minerals. That's why you should always examine the surrounding landscape carefully before investing time in detailed sampling. Look specifically for termite mounds positioned where ancient streams might have deposited heavy minerals, particularly at the inside curves of old creek beds, in areas where multiple drainage channels converge, or on terraces that represent former stream levels. Here's what most people don't realize about seasonal and climatic factors. In areas with distinct wet and dry seasons, focus your efforts during the dry season when termite activity is highest and soil conditions are optimal for processing. During wet periods, soil becomes muddy and difficult to process. Plus, termite colonies often seal their mounds and reduce surface activity. The geological age of your target area also matters significantly. Look for regions with Precambrian rocks. These are the oldest rocks on Earth, typically over 540 million years old. Most significant diamond and gold deposits are associated with these ancient rock formations because they've had the longest time for geological processes to concentrate valuable minerals. You can identify Precambrian areas using geological survey maps available online through government geological agencies. These areas often appear on maps as distinctly colored regions, labeled with terms like Archean, Proterozoic, or specific formation names that indicate very old rocks. Layer 3. Practical methods. All you have to do is follow this step-by-step extraction system that requires less than $25 in basic tools and can be implemented by anyone, regardless of experience level or physical strength. Here's exactly how to do it. Broken down into manageable stages that prevent you from making the costly mistakes that cause most beginners to give up before finding anything valuable. Complete tool requirements. Small, pointed garden trowel, $4 to $6. 5-gallon plastic bucket with lid, $3 to $4. Fine mesh sieve or classifier, 1/4 inch openings, $8 to $12. Gold pan or large metal bowl, $10 to $15. 10 times magnifying glass or jeweler's loupe, $6 to $10. Small plastic containers with tight lids for samples, $3 to $5. Spray bottle for water, $2 to $3. Small brush for cleaning specimens, $2 to $3. Notebook and pencil for recording locations, $3 to $4. Step 1. Systematic sampling protocol. Start by carefully examining the termite mound structure before disturbing anything. Take photos or make sketches showing the mound's position relative to nearby landmarks, drainage features, and other termite colonies. This documentation becomes invaluable when you want to return to productive sites or when you're trying to understand patterns in your local area. Never completely destroy an active termite mound. These structures represent thousands of hours of insect labor and play important ecological roles. Instead, carefully dismantle one section of the mound, preferably from the back or side, where your activity won't interfere with the main entrance tunnels. Take soil samples from different depths and different areas within the mound structure. Focus particularly on the interior chambers where termites store their most carefully processed and sorted soil materials. These chambers often contain the highest concentrations of heavy minerals because termites naturally sort materials by weight and size during construction. Step 2. Initial processing and concentration. Fill your bucket approximately 1/3 full with termite soil samples. Don't overfill, because you need room for water and mixing. Add clean water gradually until you create a thick, soup-like slurry that allows particles to move freely, but isn't so thin that lightweight materials get washed away immediately. This is the technique that changed everything for me. The water temperature matters more than most people realize. Slightly warm water, not hot, just warm to the touch, helps break down clay bonds and allows particles to separate more effectively than cold water. If you're working in cold conditions, let your water warm up to air temperature before adding it to the soil. Stir the mixture gently but thoroughly, using your hands or a stick. Aggressive mixing can damage fragile mineral specimens and break apart crystals that would otherwise be easy to identify. The goal is to suspend lightweight materials while allowing heavy minerals to remain near the bottom of the container. Step 3. Gravity separation process. Here's what most people don't know about effective gravity separation. The settling time is absolutely critical, and it varies depending on soil composition, water temperature, and particle size distribution. Allow the slurry to settle for a minimum of 10 minutes. 15 minutes is even better if you have time. During settling, you'll notice distinct layers forming in the bucket. The bottom layer contains the heaviest materials. This is where diamonds, gold, and other valuable minerals will concentrate. The middle layer typically contains quartz, feldspar, and other common rock-forming minerals. The top layer holds organic debris, clay particles, and other lightweight materials. Carefully pour off the top 2/3 of the water and suspended materials, preserving the concentrated heavy material at the bottom. This step requires patience and careful technique. Pouring too quickly can disturb the heavy mineral concentration and wash away your valuable finds. Step 4. Fine screening and classification. Transfer the concentrated material to your fine mesh sieve or classifier. The purpose here is to separate materials into size fractions, making visual inspection much easier and more effective. Work with small amounts at a time. Overloading your sieve makes it impossible to see individual particles clearly. Use gentle circular motions combined with light water. Flow from your spray bottle to wash away remaining clay and organic debris. Professional prospectors know that patience during this stage is absolutely crucial. Rushing the cleaning process can cause you to lose small but extremely valuable specimens that might represent significant finds. Step 5. Visual inspection and preliminary identification. Wait until you see what happens next. With clean, concentrated material separated by size, transfer small amounts to your gold pan or metal bowl for detailed examination. The metal surface provides excellent contrast for identifying different mineral types and metallic particles. Use your magnifying glass to systematically examine each suspicious particle. Look specifically for the visual characteristics we covered in the identification section: metallic luster for gold and other metals, adamantine brilliance for diamonds, and the distinctive colors and crystal forms of indicator minerals. Step 6. Sample collection and documentation. Any potentially valuable specimens should be carefully collected in separate containers with detailed location and date information. Even if you're not certain about identification, collect suspicious materials for later analysis. Many valuable finds are initially overlooked because they don't match preconceived expectations about appearance. Document everything thoroughly. GPS coordinates if available, detailed written descriptions of the termite mound characteristics, photos of the surrounding area, and notes about associated minerals or unusual soil features. This documentation becomes invaluable for pattern recognition and site evaluation. Safety considerations and best practices. Always obtain explicit permission before sampling on private property. Many of the most geologically promising areas are on private land, and trespassing can result in serious legal problems, permanent loss of access to good locations, and potential criminal charges depending on local laws. Here's the part that surprises most people. Some termite species, particularly in tropical and subtropical regions, are extremely aggressive and deliver painful bites or stings. Wear heavy gloves, long sleeves, and closed shoes when working around active colonies. If you encounter large numbers of winged termites, reproductive swarmers, that usually indicates peak colony activity. Wait a few days before sampling to avoid aggressive defensive behavior. That's how you'll avoid the most common mistakes that cause beginners to miss valuable finds. Rushing through the gravity separation process. Using too much water pressure during screening, failing to properly concentrate heavy minerals before visual inspection, and not maintaining adequate documentation for future reference and pattern recognition. Layer 4. Advanced recognition techniques. Now, here's where it gets genuinely advanced. And this is the level of knowledge that separates weekend hobbyists from serious prospectors who consistently make valuable finds. Recognizing quality gems and assessing their potential value requires understanding the shape variations, formation characteristics, and quality indicators that separate valuable specimens from industrial-grade materials or common minerals that novices consistently mistake for treasure. Diamond quality assessment. Advanced techniques. The secret is understanding crystal habits and how they relate to formation conditions and ultimate value. Gem quality diamonds typically exhibit octahedral, 8-sided pyramid, or cubic, 6-sided box, crystal forms, even when found as broken fragments in termite soil. These crystal shapes indicate specific formation temperatures and pressures that typically produce the highest quality gems. Industrial-grade diamonds, which still have value but significantly less than gem quality, often appear more rounded or show dodecahedral, 12-sided crystal faces. These rounded forms indicate different formation conditions, typically involving more violent transport or longer exposure to corrosive conditions that reduce gem quality while maintaining industrial utility. Here's what professional diamond sorters specifically look for when evaluating rough diamonds. Resorption features. These are natural etchings on diamond surfaces that create distinctive triangular and geometric patterns. These features form when diamonds are partially dissolved by kimberlite magma during transport to the surface. High-quality, gem-grade diamonds show minimal resorption. Their surfaces remain relatively smooth, with clear crystal faces visible. Lower-grade stones appear heavily etched, frosted, or show deep triangular etch pits that indicate extensive resorption. While these diamonds are still valuable, they typically end up in industrial applications rather than jewelry. Color grading in rough diamonds follows completely different rules than finished, polished gems, and this knowledge can prevent costly mistakes in field assessment. Unlike what most people think, slight yellow or brown tinting in rough diamonds often indicates potentially high-quality stones, while completely colorless rough diamonds might actually be lower-grade industrial material. Look specifically for Cape Series coloration, subtle yellow tints that range from barely perceptible to light yellow. These colors in rough diamonds often indicate stones that will grade as valuable near-colorless gems after professional cutting and polishing. Gold quality indicators, advanced assessment. That's how you'll definitively distinguish native gold, high purity, maximum value, from fool's gold, pyrite, and other gold-colored minerals that fool inexperienced prospectors. Native gold displays a characteristic buttery yellow color under magnification that remains consistent regardless of lighting conditions. The malleability test is absolutely critical. Real gold remains soft and moldable. You can dent it with a fingernail, small knife blade, or even a wooden stick if you apply sufficient pressure. Gold will deform and show permanent indentations without cracking or breaking apart. Pyrite, fool's gold, in contrast, appears more brassy yellow with greenish overtones under careful examination. More importantly, pyrite is brittle and will shatter, crack, or break into fragments when pressure is applied, rather than deforming like real gold. Fineness assessment. Determining gold purity in field conditions can be estimated using visual and physical tests that provide reasonable accuracy without expensive equipment. High-quality gold, 18 to 22 karat purity, maintains absolutely consistent color throughout the entire particle, regardless of size or shape. Lower quality gold alloys show color variations between different areas of the same particle, magnetic attraction due to iron or nickel content, or surface tarnishing that indicates base metal contamination. Pure gold never tarnishes or changes color under normal environmental conditions. Common mistakes that cost beginners thousands. Here's the part that surprises most people and causes them to literally throw away valuable finds. Many beginners automatically discard bort, industrial diamond, thinking it's worthless. But bort currently sells for $3 to $7 per carat to industrial users for cutting tools, drilling equipment, and abrasive applications. While bort isn't suitable for jewelry, it still represents significant value. And, more importantly, its presence definitively indicates you're working in a productive diamond field. Finding bort should encourage continued prospecting in the same area, rather than disappointment about gem quality. Mistake number 2. Confusing garnets with rubies causes beginners to either get overexcited about relatively common minerals, or to discard valuable indicator minerals. Both appear red, but the differences are crucial for proper identification and value assessment. True ruby has a hardness of 9 on the Mohs scale, nearly as hard as diamond, and often shows asterism, star patterns visible when viewed under direct light from specific angles. Ruby also exhibits fluorescence under ultraviolet light, appearing bright red or pink even in artificial lighting. Garnets reach only 7 to 8 hardness, lack asterism, and don't fluoresce under UV light. However, garnets are valuable indicator minerals that suggest diamond deposits nearby, so they should never be discarded or ignored during fieldwork. Value assessment techniques, professional methods. Professional prospectors know that size absolutely isn't everything when assessing potential value. A 0.5 carat gem quality diamond with good clarity and minimal inclusions is worth significantly more than a 2 carat heavily included industrial stone. Quality assessment requires systematic evaluation of multiple factors. For diamonds, look for transparency, ability to see through the stone clearly, minimal inclusions, internal flaws or foreign materials, and good crystal face development. Flat, mirror-like surfaces that meet at precise geometric angles. These characteristics indicate formation under stable conditions that produce gem-quality material. For gold, grain size and purity determine value much more than total weight alone. Fine gold dust might assay at 95 to 98% purity and command premium prices, while large nuggets sometimes contain only 70 to 80% gold, due to natural alloying with silver, copper, or other metals during formation. Advanced shape recognition becomes crucial for identifying valuable finds that don't match typical expectations. Placer gold, gold that's been transported and deposited by water, often appears as flattened flakes, worn nuggets, or irregular wire-like formations, rather than perfect crystalline shapes. Crystalline gold, gold that formed in place within quartz veins, shows more geometric shapes, including cubic crystals, dendritic, tree-like formations, and octahedral structures. Crystalline gold typically commands higher prices than placer gold due to its rarity and collector appeal. Climax and final reveal. Here's exactly how to confirm your finds at home using the comprehensive validation system I promised at the beginning of this video. You're about to learn the complete 3-step confirmation process that gives you absolute certainty about what you found, eliminates expensive appraisal costs, and prevents the embarrassing mistakes that cost beginners their credibility and confidence. Confirmation. Test number 1. The Mohs scale hardness progression. All you have to do is systematically test your specimens using the Mohs scale progression with items you already own or can obtain for less than $5. This test alone eliminates 90% of false identifications and gives you definitive answers about mineral identity. Here's the complete testing sequence. Fingernail, 2.5 hardness. Softest reference point. Copper penny, 3.5 hardness. Readily available, consistent hardness. Steel nail or knife blade, 5.5 hardness. Common tool hardness. Window glass or mirror, 6.5 hardness. Uniform hardness reference. Quartz crystal or sandpaper, 7 hardness. Hardest common reference material. For diamond identification, your specimen must scratch every single item in this progression without being damaged itself. Diamond registers 10 on the Mohs scale. the absolute hardest natural material. So, authentic diamond will effortlessly scratch quartz, glass, steel, and everything else you test it against while showing no damage to its own surface. Here's what professional gemologists specifically look for. When you scratch glass with a suspected diamond, the scratch should be clean, deep, and permanent. Fake diamonds, glass imitations, and synthetic materials either won't scratch glass at all, or they'll create shallow marks that can be polished away with minimal effort. The critical distinction that separates real diamonds from every imitation, true diamonds, maintain their sharp crystal edges and polished surfaces even after aggressive hardness testing. Cubic zirconia, glass, and other diamond simulants show chips, scratches, or surface damage when subjected to the same hardness tests. For gold confirmation, authentic gold should be soft enough that a steel knife blade leaves permanent indentations, but hard enough to resist damage from copper or fingernails. The indentation should be smooth and permanent. Real gold deforms plastically, rather than cracking or chipping like pyrite or other metallic minerals. Equipment needed: digital kitchen scale, accurate to 0.1 grams, graduated measuring cylinder, or clear measuring cup with precise volume markings, clean water at room temperature, thin thread, or fishing line. Step 1. Weigh your specimen completely dry and record the weight in grams. This is your dry weight measurement that forms the foundation for all subsequent calculations. Step 2. Fill your measuring container with exactly 100 milliliters of clean water, and note the exact water level. The water temperature should be room temperature. Hot or cold water can affect measurement accuracy. Step 3. Tie your specimen securely with thread and completely submerge it in the water without touching the container walls or bottom. Record the new water level. The difference between initial and final water levels equals the specimen volume in cubic centimeters. Step 4. Calculate specific gravity using this simple formula. Specific gravity equals dry weight in grams divided by volume displaced in cubic centimeters. Diamond confirmation. Authentic diamonds show specific gravity between 3.50 to 3.53. Common diamond imitations show dramatically different values. Glass, 2.4 to 2.8. Quartz, 2.65. Cubic zirconia, 5.6 to 6.0. And moissanite, 3.2. Gold confirmation. Pure gold registers 19.3 specific gravity, but natural gold alloys typically range from 15.5 to 18.5, depending on silver, copper, and other metal content. Pyrite shows only 5.0 to 5.2 specific gravity, less than 1/3 of real gold. Confirmation. Test number 3, the definitive streak test. This is the technique that eliminates every remaining doubt about mineral identification, and it requires only a piece of unglazed ceramic tile. The back of a bathroom tile works perfectly and costs nothing if you have access to home improvement scraps. Here's what blows most people's minds about streak testing. The color of a mineral streak, the powder it leaves when scraped across ceramic, often differs completely from the mineral's surface appearance and remains absolutely consistent regardless of surface tarnishing, weathering, or external coatings. Gold streak characteristics. Authentic gold produces a bright, metallic yellow streak that maintains its brilliant color even when the powder is extremely fine. This streak color remains unchanged regardless of the gold's surface appearance, purity level, or alloy content. Pyrite produces a distinctive greenish-black or dark gray streak that immediately reveals its true identity. Brass, bronze, and other gold-colored alloys create streaks that range from gray to reddish-brown, but never show the pure yellow color of authentic gold. Diamond streak testing requires special technique. Because diamond is too hard to leave a streak on ceramic, you're looking for the opposite result. Diamonds will not produce any streak at all on ceramic surfaces, while softer look-alike materials will leave visible powder traces. Final value, assessment, and next steps. Here's exactly what to do once you've confirmed authentic finds using all 3 testing methods. Your next actions determine whether you've made a hobby-level discovery or identified a potentially life-changing mineral deposit that justifies serious development. For confirmed diamonds, document exact location coordinates, photograph specimens in situ before removal, and map the extent of diamondiferous termite colonies in your discovery area. Contact your regional geological survey office for information about mineral rights, claim procedures, and professional assessment services. For confirmed gold, systematic sampling becomes crucial. Test multiple termite colonies within a 1-kilometer radius of your initial discovery. Gold occurrence is typically concentrated in specific geological zones, so additional finds nearby strongly indicate potentially commercial deposits.